In this question about running the 100-meter dash, it looks like they took it easy on you here. You're going to have to use dimensional analysis. So I'm going to convert 12.5 seconds to minutes. So in this case, I have to do 12.5 seconds times 1 minute over 60 seconds. So these seconds labels are going to cancel. I'm going to do 12.5 times 1. I get 12.5 divided by 60. So when I put this in my calculator, I get 0.20833 minutes. And what you notice that this is choice number 1. To start off this problem, I distributed the 5 and I get 5x minus 20 on the right side of the inequality. I am going to continue on to solve. I get 2 is less than or equal to 2x minus 20. Add 20 to both sides. I get 22 is less than or equal to 2x. Divide by 2. X is less than or equal to 11. You could flip this around and say x is greater than or equal to 11, which it looks like this case it would be choice number 4. When you're simplifying number 10, I distributed 3 times x squared, 3 times 1. Now, because of this minus sign, when you're dropping the parentheses, you're going to have to change all of these signs because you're basically distributing a negative 1. So 3x squared minus x squared, you get 2x squared plus 7x, and then this is acting like a negative 3 minus 10, so we're going to say minus 13. So this is actually matches up with choice number 2. The range of the function f of x equals 2x squared plus 2x minus 8 is all real numbers. Less than or equal to negative 9. Okay, I see. There are going to be new 4 choices here. So the range means how high and how low the graph goes. Pardon my rough sketch of the parabola here. The parabola actually crosses the y-axis as negative 8, but at negative 1, I believe that this lowest value here is going to negative 9. So when we're talking about range, we're talking about, which y values are we using? What's the minimum y value that's being used? We're looking at the vertical direction when we're talking about range. So we're going to say that this range is greater than or equal to negative 9. This graph is above, it's more than, it's greater than or equal to negative 9. And number 12, this is my favorite question on the exam because I feel like it's the easiest. The zeros of the function x squared minus 5x minus 6 are, remember, the zeros are where the graph, are there the x values where the graph crosses the x-axis. So in this case, if you look at your graphing calculator, if you put this into your y equals in your graphing calculator, you'll see that it crosses at negative 1 and 6. Another alternate solution I want to show you is that if you plug in these values, so if you were to plug in 6 throughout this, you're going to see that you're going to get 0. Okay, there's no coincidence that when you plug in these numbers, you're getting 0 as your value. That's basically what you're plotting on your graph, and coincidentally, that's where it is on the x-axis. (13), I think they want you to overthink this a little bit. In a sequence, we know that our first number is 4. And we know that the difference between this number and this number is 3. So what that means is the next number is 7. Now, I understand difference means subtraction to you, and you might subtract 4 and get 1 and then negative 2 and so on and so forth. But when you find the difference, when you're finding the common difference, what you're doing is you're subtracting the second term minus the first term. Okay, so when I do 7 minus 4, I do indeed get 3. So 4, 7, 10, 13, 16. Now you could also use the formula a sub n equals a sub 1 plus n minus 1 times d. You could say, hey, what's the fifth term? Well, I know the first term is 4. I know I'm looking for 5, so my n is 5, and then the difference is 3. So what you do is you say 4 plus 4 times 3, and you get 16 the same way. Okay, so there's two alternate solutions. There's way number 1, and then there's the second way with the formula.